To explain this algebraic inequality that often trips up students, we first have to establish why when you divide or multiply by a negative when it's an inequality, you have to switch the sign. So when you asked your teacher back in the day, I don't think she gave an explanation. If she did, I don't remember. So the simplest way is just to do some examples, and we're going to expand from this. So 2 smaller than 3. So if you multiply or divide both of them by -1, is -2 smaller than -3? No, it's not, right? It's bigger than -3. So very quickly, just by doing an example, you can see that when you divide or multiply by the same thing, so keeping the inequality the same, and it's a negative, you have to switch the sign to make the inequality truthful. So now we can use an algebraic one. So let's say it's -x is smaller than 2. So what fulfills this? Well, x can be 2. If x is 2, then -2 is smaller than 2. So let's say we multiply both sides by -1. And let's say we don't flip the sign. So now we have x is smaller than -2. Does this still hold? Well, is 2 smaller than -2? No, it's not. How do we make it hold? We flip the sign. 2 is bigger than -2. So we can prove this by doing a bunch of examples. But let's really think about it algebraically. So let's say a is smaller than b. If we subtract a from both sides of the equation, again, to keep the inequality the same, then we would get 0 is smaller than b minus a. Maybe here we have to very quickly explore the first principle of why we always add or subtract or multiply or whatever, the same thing on both sides of the equation. So it made sense when things were equal, right? When things were equal, you'd be like, well, if it's equal, well, you got to do the same on this side and the other side. Right now, we don't really have an equal sign. We have an inequality, right? So the way I would describe it is, think about what happens. Let's say you -2 on one side, then you -2 on the other side. What happens if you had to move both of these to the same side? They add up or subtract to 0. So essentially, when you're doing the same thing on both sides of the equation, so to speak, you're basically adding a 0, but you're taking the 0 and making it into 2 terms, and then you're putting one of the terms to the other side. You can think of the equal sign, but in cases when it's not an equality, think about the 0. You're trying to keep it unchanged, right? Adding 0 to anything is still that same value. 0 can be made up by the sum, the difference, etc. of many, many different values. You do one value, subtract that itself, or one value plus the negative of itself, and you can move one of the values over to the other side. Anyways, long story short, to keep this inequality the same, subtract a on both sides. So now that means 0 is smaller than b minus a. Put some numbers into this. 2 smaller than 3, that means that 3 minus 2 is bigger than 0, right? If there's a difference in value between the two numbers and one is bigger than the other, you subtract them, they're not going to make a 0. I think it's pretty logical to think like that. So now what do? Subtract b on both sides. So now we get -b is smaller than -a. Look what we just proved. -a is bigger than -b. If we were to just multiply or divide a -1 to both sides, we would switch the sign. So we used algebra, addition and subtraction, algebra, to prove that if we multiplied both sides or divided both sides by a negative, we would switch the sign. So this is how you prove it algebraically. I don't think teachers ever showed this to me, but I'm showing this to you now. So again, the lesson, when you're working with inequalities and you are multiplying or dividing by any negative value, you have to switch the signs. So now we're given a problem like this. 2x minus 3 divided by x plus 1 is smaller or equal to 1. What is the first instinct a student might do? A student might want to multiply the x plus 1 on both sides, and that way we get a pretty simple algebraic solution. But let's go back to what we just learned. And we have to pull in a first principle from algebra, which is, what does x mean? X means it's unknown. What does an unknown number mean? It means it could be -2, it could be 1,000,000, it could be 0, it could be -0.5, it could be 6.3. Notice what I just described. We don't know if this denominator, the bottom of the fraction, is a negative or a positive. So if we just multiplied both sides by x plus 1, since we don't know if this value is negative or positive, we don't know if we can switch the sign, / if we need to switch the sign. So we can't just multiply both sides by x plus 1. So what do? We have to do it a little bit more complicated. We have to subtract the 1 over, and we have to solve it by doing some fractions, guys. So let's solve it, guys. We already explained this part. So now we subtract 1, and we know first principle wise that anything divided by itself is 1. So we have x plus 1 divided by x plus 1. Why do we want to do this? Because x plus 1 is the denominator here. So we're trying to combine the two terms, and maybe we could get something simpler. So here, since it's minus, distributive property, guys, so that is also a first principle. So we distribute the negative 1 into both. So we get 2x minus 3 minus x minus 1 divided by x plus 1, and smaller or equal to 0 because we subtracted the 1 from both sides. So now we do the arithmetic on the top, and we see if there's a way to simplify it even more. Unfortunately, the simplest we can get is this. X minus 4 over x plus 1 is smaller or equal to 0. So for those of you who remember your math, what do we do now? This is unfortunately a plug-in, trial and error part. We have to figure out the asymptotes where it's undefined. So it's undefined at -1. And then we have to figure out where, as in what x values, fulfill the fact that the left side of the equation will be smaller or equal to 0. There's a little bit of trial and error plug and play, but this is the fun / the tedious parts of graphing. And I don't know if this is pre-calculus or algebra 2, but we're going a little bit beyond what we tried to explore today earlier. If you guys want me to solve this, I can solve this in the pinned comments. But the point is, the bottom could be negative or positive, and because of that, it changes how we can do algebra when it comes to inequalities. So as a student, just remember, if the denominator were not an x or x squared or something that we don't know the value of, so a variable. So for example, if the denominator were a 2 or a 6 or a 1000, we are okay multiplying both sides by the denominator and simplifying this the way that your instinct wanted you to. Because the denominator, we don't know if it's a negative or a positive, we had to get a little bit complicated. We started with this first principle. Don't just memorize. Don't just memorize. Because if all you do is remember, oh, if you divide or multiply both sides by a negative number, you have to switch the sign, somewhere down the line, you're probably going to make this mistake because you forgot, first principle wise, why we have to switch the sign when it's a negative that you multiply or divide by both sides. Understand it from the first principles. It'll make your math journey more fun and fewer headaches. Thank you guys so much.